Right, let's get started. So today we are going to be talking about a very um, important topic of mathematics, a very fundamental topic. But things in this topic they can go pretty advanced, right? They can go pretty far, and it is a topic that if you can master, your life will be set. This topic is none other than trigonometry, right? It is important in architecture, right? It is important in engineering, all right? It is very important in the aerospace industry. Also, if you want to become a physicist, trigonometry is one of the core subjects of math. So, in today's video, we are going to be discussing the fundamentals of trigonometry, building concepts from beginner's level and taking you up to some basic um, sum and difference identities. So let's start with trigonometry. First, let's take a triangle. I'm sure we all know what a triangle is. A triangle is a three-sided polygon. Now there are a few like cases of triangles. You've got equilateral triangles, scalene triangles, isosceles triangles, and right-angled triangles. For trigonometry, the one we will be requiring is this one. A right-angled triangle is a triangle in which one of the angles is 90 degrees, right? Has to be 90 degrees. So all of these are right-angled triangles or RAT. Okay, let's talk about why right-angled triangles are so important in trigonometry. Suppose you have a really big right-angled triangle, right? Excuse my drawing, right? Suppose this angle is 90 degrees. Let's call this side A, this side B, and this side C. All right. So in trigonometry, you need to take any of the angles except the one which is 90 degrees. So you can take angle A or you can take angle C. Suppose let's take angle C. Right, let's give angle C a name, theta. All right. So theta is our reference angle. What I mean by reference angle is the stuff I'm about to write now, you are supposed to look at it from this angle, right? So put your eye here. This is your reference angle, all right? And let's name this angle, angle A, phi, all right? All of these are Greek letters. We'll call it phi. You can even write it like this. It's up to you. So let's talk about some trigonometric ratios. First, we've got the sine of theta. The sine of theta can be written as perpendicular by hypotenuse. Now, from Pythagoras' theorem, we know that the hypotenuse of a triangle is the longest side of a right-angled triangle. The hypotenuse is the longest side of a right-angled triangle, which is, so here AC is the hypotenuse, right? So which one is the perpendicular? AB could be a perpendicular, or BC could be a perpendicular, but our angle of reference is theta. So if we're looking from theta, right, AB, this is our perpendicular. So the sine of theta would be AB by AC. Similarly, the cosine of theta, which we write as cos theta, is base by hypotenuse. So with reference to theta, what's our base? BC, and our hypotenuse remains constant, so it's AC. So our sine theta is AB and by AC, and our cosine theta is BC by AC. I hope that we're all up to track so far. Now, we will be moving forward to the next ratio, which is tan theta. Tan theta is not, like, it can be simplified into a side-by-side ratio, but the fundamental definition of tan theta is sine theta by cosine theta, or we can write this as AB by AC divided by BC by AC. This can be written as AB by AC into AC by BC. Got AC and AC getting canceled. So you've got AB by BC. What is AB? What do we see AB as? AB is our perpendicular and BC is our base. So from here, we get base, perpendicular divided by base equals tan theta. We've got 3 more ratios to go with, and after that, that will be the end of today's video. This will be a series in which I keep developing your concepts until we reach basic sum and difference identities. And after that, we will progress with doing some basic numericals. Right. 3 more. We have got cosec theta, which is 1 by sine theta. We've got sec theta, which is 1 by cosine theta, and cot theta, 1 by tan theta. This is hypotenuse by perpendicular. This is hypotenuse by base, sorry. And this is base over perpendicular. As long as you know the values of sine theta, cosine theta, these two only really, you can find out the values of all other trigonometric ratios. How do you do that exactly? Well, tan theta is basically 1 by sine theta by cos theta. Cosec theta is a reciprocal of sine theta. Sec theta is a reciprocal of cos theta. Cot theta is the reciprocal of tan theta. So here you have it. These are the six trigonometric ratios derived from a right-angled triangle. The next day, we will be learning some basic identities such as sine squared theta plus cos squared theta equals 1, and the further applications, dividing them by sine theta, dividing them by cosine squared theta, my bad, sine squared theta and cosine squared theta, seeing how we can manipulate various equations. But for that today, you need to wrap your mind around this and revise your concepts well, because if your base isn't clear, you will never be able to grasp the advanced topics. That's it. Thank you for today.